So, hey everybody, my name's Paul. I just help with some of the community efforts here for Apache Cassandra. And today we have Jaydeep. He's going to be talking about CEP 37, Apache Cassandra official repair solution. So he's going to be presenting some of the work he's been doing there. And he would, if you have questions, you can feel free to add them in the chat. If you feel like it's something that's really relevant to what he's talking about and you want to jump in there, just raise your hand, with Slack, because JD wants to answer your questions as they come up if they're particularly topical. Anyway, I'll hand it over to JD and he'll do his thing. All right, go for it, Jaydeep. Oh, maybe he froze. Oh, there you go.
Sorry, my video was probably frozen. Am I good to start?
Yeah, go for it. Yeah.
Okay. Hey everyone. Good morning, good evening, good afternoon, depending on the time frame you are in. My name is Jaydeep, and I'm a software engineer at Uber. Me and my team have been running Cassandra at Uber. So today we are going to discuss about CEP 37. Let me share my screen and then we can get started. Okay, can all of you see my screen here?
Yeah.
Okay. Okay, so just to give a little bit background here. There is repair is basically like no one has like anti-entropy etc. in the Apache Cassandra, right? So I'll just spend a couple of minutes to go over why repair is essential, as I think many of you already have been using Cassandra, so you already know the importance of repair in Cassandra. So Cassandra being an eventual consistent system, we need to run repair in order to synchronize the data, primarily due to a few reasons. So one is when Cassandra writes, we generally use most likely column consistency. So not all the nodes would have the data. So in order to make sure all replicas get the data, repair is the one that is going to propagate the data to all the replicas. Second, most important thing is when many times when we run Cassandra, it is located in multi-regions. So when we generally write, in most cases, we generally write it to one region and then data will be replicated to another region. As you already know that Cassandra, when you write to the primary or one region, the replication is not guaranteed. So it is kind of best effort replication to another region. And if the data is not available in the region, the way to propagate the data is through repair. And third important reason why we need repair is as many of you know that in Cassandra, when we kind of delete the data, Cassandra does not guarantee that the data will be deleted at the same time from the disk on all the nodes. What Cassandra does is actually it marks the data as tombstone, and after the GC grace second, it will actually purge those tombstones. What could happen is if those tombstones are not propagated to all the replicas, we could end up with data resurrection. So in any of these scenarios, if data become inconsistent, it could be a disaster kind of situation for the applications relying on Cassandra. So let me go straight into the CP 37. So one thing I wanted to highlight is this topic has already been kind of being discussed in the Cassandra dev mailing list multiple times in the history, and more recently you can go through. I'll just show you my screen here. And later on I will share this email thread as well through the archive. but this is the most recent discussion we have had on repair in Cassandra. So feel free to go through this, kind of email chain if you have not, got a chance to go through it. So this CP is nothing but kind of, some summarizing the discussion from that email thread to an official kind of, CP request here. Motivation, I won't go much into why we need repair, because repair is essential for Cassandra to function. And sometimes, we kind of feel that, okay, it is an optional tooling or optional mechanism, but as I discussed, that it is not an optional thing. We need to have repair running in order to maintain the data consistency in Cassandra. And if we don't run repair, it could lead to inconsistency, data resurrection, which could mean different things to application. And depending on the business use case, it could mean from small kind of business problem to a larger business problem. So repair, again, it is not a new topic altogether. This has been available and widely discussed, one of the widely discussed topics in the Cassandra history. The main thing that we have noticed is, despite Cassandra being in the market for so many years, there is not an official Cassandra repair solution currently available. There have been so many solutions proposed and adopted by various people. Some of them are like uh, uh, control plane based solutions, where people do rely on control planes to trigger repair externally and orchestrate that repair outside of the Cassandra. There are some solutions which kind of rely not on orchestration layer outside of the Cassandra but inside the Cassandra. So here but all of these solutions are customized and kind of developed for for probably one corporation to another corporation, and people have kind of tuned it according to their needs. So so main idea here is, because repair is very essential, as we discussed, and there is no official repair solution available, it sometimes creates basically a problem for newcomers who wants to use Cassandra, because if you want to use Cassandra, if you don't run repair, what would happen is, like, it will lead to data inconsistency, data resurrections, and what would happen is, people might interpret that, okay, Cassandra is not maybe working well, or is not the right fit for their needs. But the thing is, if you use Cassandra in the right manner with all the necessary tooling and mechanisms, then it works a majority of the times. So the goal for this proposal is to basically align, among, as I mentioned before, there have been numerous solutions available, which kind of takes care of Cassandra's repair or anti-entropy mechanism. So one of the goals is to align among the existing solution and have it officially blessed by the Apache Cassandra officially. Second goals is basically to ensure that the solution, whatever solution that we as a community pick, should be very easy for an operator to manage, so that there is no need for kind of manual intervention. Because when we run Cassandra at scale, like if we run like one or two clusters, it might be easier to manage. But if we start talking about hundred or thousands of Cassandra unique clusters, tens of thousands of nodes, petabytes of data, then any single manual interventions becomes a hurdle, and it actually limits the growth and the scale of Cassandra. Um, so so here what we are trying to say is, as part of this CEP, is we as I mentioned, like there have been people already using repair in their premises. So the idea for the CEP is not to tell them to stop their own repair and kind of migrate to whatever repair solution that we kind of come up with as part of this particular CEP. We at least should be cognizant that the existing people, because migrating from their own existing repair solution to the newly or to the officially blessed version would take time. So what are solution that we pick as a community should basically be capable of kind of working with the existing solution. I mean, it should not break the existing solution that people have been using. And second thing is, for the newcomers, we should basically recommend the solution that we pick out of this CEP. One of the known goals here is, as I mentioned, there are two ways we can run repair in Sandra. One is like, I mean, there have been like numerous solutions proposed. Those basically fall into two categories. One is externally triggered repair mechanism. That means, the repair has been triggered as part of, some control plane, and the entire orchestration of the repair sits outside of the Cassandra. And the second class of solutions is about repair running or repair orchestration running within the Cassandra itself, very much like compaction. So next we go like proposed changes. So again, I wanted to highlight that this is a draft CP. So the list here is not exhaustive. This is basically based on the email thread that I described previously. We kind of have kind of highlighted 2-3 solutions, and that's why I put these 3 solutions. So if you feel there is a repair solution that has been there and working at scale, feel free to either reply to that email thread or shoot me an email, and we can definitely extend the list here to include the solution that you have been working on or you have developed. So primarily, there are kind of 3 solutions we have kind of narrowed down from that email thread discussion. Again, the names differ, but the purpose is the same. All of them, I think, by and large, schedules repair within the Cassandra itself. So one of the solutions is basically ticket 14346 proposed by Joy. That also talks about what exactly can be done. And if you this is basically a summary that I have kind of copy pasted from this ticket, and we can see that Joy has been talking about how it can be used and how they are using this particular repair solution. This is probably proposed in I believe late 2016, 2017 or 2018. There's another solution which has been proposed by Marcus. This was probably proposed long back in 2014 or 2015 timeframe, which also very much talks about the repair solution inside the Cassandra, without any control plane dependency. And the third one is basically a repair solution, which I will talk a little bit more in this particular meeting. There is no ticket created on it because this was again being discussed on the same email thread. There has been a design doc published for this one. There is a private fork available, and there was an active kind of Slack discussion happen probably in the November timeframe. Before I jump into solution 3, I'll just go over the structure of this document. Um, and then we'll go a little bit more into this particular solution. So you can see a lot of these things are to do because we have not yet kind of finalized the solution that we as a community would like to move forward with, because that is open for discussion. The idea for the CP is to kind of streamline some of the solutions and start engaging and discussions within the community. So hopefully we arrive at some consensus on the repair solution that we as a community would like to bless with. Compatibility, deprecation, migration plan, a lot of these things are to do. The test plan is pretty high level, where we want to at least ensure that it should be operationally extremely easy to manage, and it should scale as well. There have not been any rejected alternatives and so on, because we are at this time in process of collecting all the feasible and scalable solutions, so that we can do further discussion on it. With that, I'll straightly go into this particular design high level, and then let me increase the fonts here. Okay, so I will not go into proposal and high level aspect here, because this in a way we have already discussed. I'll straight away go into the architecture of this particular solution. So the idea here for this particular solution is to rely on Cassandra itself to orchestrate the repair. So for an external user point of view, if the way they don't have to worry about compaction when they start Cassandra, the idea is similar, that as soon as they start a Cassandra cluster or create a new Cassandra cluster, the repair should happen automatically, for them. The way we have achieved this particular design is by sharing the state among various nodes in the Cassandra. So in this example, we can see that there are 6 node Cassandra cluster. So the idea here is Cassandra already shares a lot of state among various nodes. For example, gossip information, schema information through system underscore distributed key space. So kind of empowering from that principle, what we have done is we have kind of introduced a new key space, we can call like system repair key space, which is again a distributed key space. So all the nodes would know the status of repair. Once all the nodes share kind of a common table, we can prioritize the repair. So what happens here is we can configure repair parallelism, like how many nodes we want to run repair at a given point of time. By default, 1 node at a time, and we can always configure that. Okay, we want parallelism of like maybe 2, 3 or so, depending on the degree seconds that we have set in our kind of environment. So let's say if we go with a default 1, what would happen is N1 initially, what we do is basically we sort this node names alphabetically, and then use that order, that okay, which node should go first in the sequence. So N1 will start. This is when we start with a clean slate solution. So N1 will start and it will advertise into the distributed key space saying that, okay, I'm the one running through the repair. So what would happen is, because the parallelism is 1, N2, N3, N4, N5, N6 would wait on N1 to finish. And when N1 is going through the repair, it also, goes in a fine grained manner, because we know that, if you just run repair on a node for a really large token range, it often fails. So what N1 will do is like it will go through table, it will go through key space by key space, and within each key space, it will go table by table, and within each table, it will split the token range into smaller chunks such that the chance of repair success is pretty high. There are like fault. There are enough retries, uh, race conditions, as well as uh, fault mechanisms have been kind of handled in this way, so that there is rarely a chance where N1 would get stuck, uh, including nodes getting added, nodes getting removed, cluster. Basically, we are scaling out cluster, we are shrinking cluster, and so on. Or rolling restart has been going on, and so on, so and so on. So once N1 finishes the repair, then the next node in the ring will go through the repair, and so on. There is also a concept of oldest repaired node. Let's say once all the nodes go through the repair cycle, right? If a new node joins, uh, then also we track that, okay, what is the repair timestamp for this particular node, and we always try to pick the node which has gone through the repair, uh, whose repair timestamp is the oldest. So I'll not go too much deep into this whole design doc, as we have kind of given a flow chart here. The flow chart is very similar to what I have described. Is very simple, where you start. Uh, am I marked as repair started? No, then again go back to the start. Um, so default is 1, as I mentioned. So am I the node which has not been repaired for the longest time among the nodes that not being repaired? And this particular thing, we are able to figure it out because we share the state among all the nodes through the system distributed key space. Uh, so if I'm the node among all the nodes not repaired, then I'm the one supposed to start, repairing myself and go through each key space, and then within each key space go through table, and then repair primary token range for this. Then there are like multiple kind of state transitions that happen here. You can see that repair, whether the repair is successful for this token range. If not, then retry, uh, and so on. Because while we are repairing, the table could be dropped. So there are all those kind of fault tolerance mechanisms taken into account. And towards the end, once the node finishes the repair, it will mark itself as repaired, so that the next node in the ring would get its chance. So this configuration options have been kind of available to be configured through node tool command, as well as through basically the YAML option. So all the options have been kind of described here in detail. And we have been running this at a pretty huge scale, like tens of thousands of nodes, running repair across like hundreds of clusters without any manual interventions required here. So in the interest of time, I think we are almost at and reaching towards the end of my session. So I'll just summarize the CEP once again. There have been like 3 solutions kind of primarily proposed here. Those are mainly coming from the email thread that is currently live in the Cassandra Dev community list. So feel free to go through it and provide your opinion there, and would love to kind of go through all opinions there. The idea here is to converge as a community on an official kind of officially supported repair solution. I think we have 5 minutes left in this session, and we'll kind of we'll kind of divert this time towards the question and answers.
Yeah, thanks so much, Jaydeep. Yeah, well, you can open up for questions. Looks like Sebastian has a question. So I think you can go ahead and unmute yourself, or do we have to allow
Yeah.
that? Right.
So first of all, thank you for the presentation and your proposal. I was wondering, how would this tool manage the interactions between full and incremental repairs? Recently, we had a discussion about this on the users mailing list, that in general, running full and incremental repairs for the same table is not a very good idea. But then full repairs, if the table is very large, can take a very long time. So you might want to run incremental repairs in between. And so what's the idea there?
Good. Yeah, that's a good point. So currently, this framework is only taking care of the full repair. We are actively working on enhancing this framework to include the incremental repair as well, so that it can work hand in hand. Of course, the cadence will be different, and we also wanted to avoid running incremental and full repair on the same table at the same time. Our current plan is to have this framework enhanced probably in by June or so. So we can have incremental repair working with the same framework.
Thank you very much for the explanation.
I have a question, if no one else has right now. So what are the next steps for you or the community in general?
I think you can see on the email thread, I think as Josh has mentioned that, now he has mentioned like let's kind of, list some of the solutions. I believe the next step from the community point of view is to maybe do some sort of discussion on moving forward with some solution, because if we keep discussing this repair thing, I don't think so we will be able to kind of reach to a consensus where it will just satisfy everybody's need here. I believe, at least this is my opinion here. I think see, people might have already settled down on their own repair solutions, right? So if we at least start thinking about newcomers, like let's say if somebody wants to use Cassandra, if we at least unlock them by giving repair solution, then I think that will be a big win, because that will actually reduce the bar for the entry for Cassandra, for people to use Cassandra, right? But I think more discussions, I would say on the mailing list, we will probably, Josh and the team will help us decide the next set of items for it, and we'll go from there.
Okay. Yeah. In an ideal world, like what would you say the timeline you would hope for to have something like this ready for use?
So for as I mentioned, so for us, this is again the pull request, etc., has been coming from the way from our experience. So for last many years, we have been already running this solution at scale. But again, this is not the solution that we are saying it should be the one that is adopted by the community as well, because we should honor and go through all the solutions available. So in my opinion, repair has gone back and forth multiple times. I think at this time we should basically come up with some list, which is the list, at least for now I have put it onto the CP. Again, this is not the exhaustive list. Feel free to add more items if you have. I think we should probably do some sort of voting or something there, and I think we should at least move forward with some solutions, so at least newcomers should start using it, and then the existing people can eventually figure out the way to migrate it to the officially kind of recommended solution.
Okay, awesome. Yeah, are there any other questions from anybody else? Well, looks like we have answered all the questions. Yeah, thank you so much. Yeah, we really hope we can push towards a consensus and move on with the solution. So thanks, Jaydeep, for taking us through that. Yeah, so I guess that's it for today. So thank you very much. Thanks for joining us, everybody.
Bye.